Hello folks, this is Tom from anti-proton.com, and I wanted to do a little quick update. There's been some questions recently about rainwater again, and we've been, testing rainwater, a lot of people, for a while now. So I wanted to test my rainwater again. I haven't actually done it, as you probably have noticed, in a while, and I wanted to see what I would find. But I didn't want to do the little 5 or 10 minute test that I had done before. I wanted to do a more statistically accurate one. And I did it, and I think I got a little bit of a result, so I'm going to try a much longer test now. Let me show you what I got for 1 hour. Here's the Geiger counter. Here's a room. It's my closet. I have a wooden board. Now, one could say, oh, the wood might have radiation in it, there could be something in it, there could be something behind this wall for all I know. So to test that, here's my bag of rainwater. It's a bag of rainwater. See the sample? It's got crap floating in it, so, who knows. I've looked at the stuff. It looks like mostly organic debris, like little pieces of wood and stuff I got out of the water. So no rocks that I see in it. But basically I took my Geiger counter and I set it up and ran it for 1 hour straight. In 1 hour, so scribble down my results here. In 1 hour, I got a total of 893 counts. That makes my background 14.8833 repeating. 14.88. When I took the rainwater sample that's in the bag and I put this on top of it so the gamma would come into it, and the reason I use gamma in this case and a weak beta is because alpha detection would require doing this, and the probability of incidence is very tiny. Like here, I'd pick up anything that had a gamma coming out of it. And cesium-137 and strontium, I think both of them will decay with gamma. I'd have to check off the top of my head to make sure that's true or not. But they should either be that or beta. And even alphas might pick up at this distance. So it's a relatively decent test. So anyhow, it exposes a pretty decent amount of my shield here to the plastic. I got a total of 925 counts in 1 hour like this. So that's 925 versus 893. That's not much. That's 7 plus 25 is 32, right? The 32 counts total more in 1 hour. It's not very much. So it's 15.4166 with the water, 14.8833 without the water. Now let's see. 1, 2, 3, 4, 4, 5, 5, 6, 7. I could run a 3-hour test if I wanted to, and I might actually consider doing that. Or even taking the water with me to work and running a test. So I'm thinking about running more like a 3 or 4 hour test to get this down exactly, to make sure that this is or is not working correctly. And if I have another rainstorm, I'll test it as well. Because people keep asking, and I keep hearing all this stuff, and people keep pulling out water that's apparently putting out 2 or 3, millirems per hour, some hideous amount of radiation that I can't imagine you'd ever detect. As you can see, I'm not getting very much off the water. This is not too much above or below background. So, anyhow, we will see. There's my water sample. As you can see, there's floaties, but they're not really rock sediment too much. Mostly just water. I got it from a little rain sample bucket container I have at work. The water falls into it while I'm working. It's right outside of the lab. And you see, here's the date on it. So we'll try some more and see what we get. Also, there could be too much fluctuation in this room for an accurate reading, but a long reading will take care of that. So anyhow, this has been the 24th, even though this is technically being uploaded on the 25th, and I'll get back to you tomorrow and see what I can pick up. I don't think that what is that? 0.8 counts per minute is really significant, but maybe a little. Anyway, this is Tom from anti-proton.com, and I'm hoping to also get into some other subjects again, because I've been doing too much with radiation recently. I'll continue to do it, don't get me wrong, but I'd like to get into mineralogy, oceanography, astronomy, and some other random things. Okay, bye-bye.